Hey kids, Mr. Murray here, back on Mr. Murray's Mathland, still talking about implicit derivatives. And today we're talking about implicit second derivatives, and I guess higher order derivatives in general. We could go to the third or fourth derivatives if we want. But notice that notation which would indicate this. Find d squared y over dx squared. So the second derivative with respect to x twice for this equation here, y squared minus x squared equals 5. And notice this that is tacked on. It says express your answer in terms of x and y. And we'll see why that kind of becomes important. But hey, we're going to start like we always do. You can't jump to the second derivative without finding the first derivative, right? So let's do it. Gotta find that first derivative here. And this one really shouldn't be too bad. We're taking the derivative of this with respect to x. And so the derivative of y squared, hey, that's not an x expression, so here's your implicit step, 2y times dy dx. The derivative of negative x squared, that's negative 2x, and that's an x, so I don't need to multiply by dx, right? That would just be 1. Derivative of 5, that's a constant. Derivative is 0. So far so good, right? Now let's solve for dy dx. I like to do this before you differentiate again to take the second derivative. I always recommend solving for dy dx. So that would be adding 2x to the other side and then dividing by 2y, right? And a lot of this could be done in your head if you're comfortable. Always nice also, this is a perfect example of 2x divided by 2y. Reduce if you can, right? Cancel those 2's. Not that you have to, not that it's going to affect your derivative, but sometimes it might make your work easier if you're working with the simplest form. So there is my derivative, and now I want to take the derivative of that to get the second derivative, right? So here we go. Now I'm taking the derivative of this, so I'll switch to a new color, very fancy, right? And so the derivative of dy dx, this is where you get that notation of, it's d squared. It's the second derivative, but it was with respect to x twice, equals, and now to do the derivative of x over y, that's a quotient rule, pretty basic quotient rule, but still, watch out for it. And so the quotient rule, your denominator is squared, and your numerator, a is x, b is y. What is a prime? That's 1. What is b prime? Derivative of y, watch out, that's 1 dy dx. So the numerator here, low d high minus high d low, or inners minus outers, however you like to remember it, that's going to be y minus x times dy dx. Okay, so I got my second derivative, right? Second derivative is this, except one problem. If you'll remember that part with the directions, it said express your answer in terms of x and y. And you might think you've done that, but x and y means only x and y, not dy dx. That's really like its own variable. So, no problem here. We're just going to take out dy dx, and what is dy dx equal to in this problem? Hey, no problem, you just take a step back. We already found dy dx, it's x over y. So I'm going to do that. Take out dy dx, replace it with what it's equal to, which is x over y in this case. Now I am going to clean this up because I don't typically leave complex fractions in my answers, and especially if this were a multiple choice problem, I can guarantee you this answer would not be written this way. So I have y minus x squared over y, once I multiply those two together, over y squared. I can guarantee you the multiple choice wouldn't be this way because it's a complex fraction right now. Let's clean that up. So I like to handle these by multiplying through by that LCD, which in this case is y. So I'm going to multiply the top and bottom of this by y. And that is going to give me, when you distribute that y through, you'll get y squared minus, and then it will just cancel with that y. So you'll have x squared over, and in the denominator, don't forget to multiply that. So y squared times that y will give you y cubed. And there is our second derivative. And that would be a perfectly acceptable answer. However, I know the problem never seems to end. However, if this were multiple choice, you might not see that answer, because you do always want to have things simplified or reduced as much as possible. And if you take a good look at this, there's one other thing you can do. So taking a step back here at the original problem, way back at the beginning here, y squared minus x squared is equal to 5. So if you'll notice, in your second derivative, you have y squared minus x squared. So you could further simplify this. It would not be required, but you could take out y squared minus x squared and replace that with y, which is a simpler expression. And so you might see that sort of thing in a multiple choice. So you just have to be flexible. You know, if you've got this, you don't see that choice, you know, you'll look around and say, what else can I do? But the real thing that this video was about was just how to take that second derivative. You know, find the first derivative, isolate dy dx, take its derivative if you have to use any quotient or product rules, and frequently you'll have to replace dy dx with what you found it to be in the previous part of the problem. Then from there, it's just all algebra. So hopefully you're feeling pretty good about implicit differentiation, first and second derivatives. If you have any questions, just let me know. Hang in there and keep working hard.